Assisted GPS is a system that is often able to significantly improve the startup performance, or time to first fix, of a GPS satellite-based positioning system. AGPS is extensively used with GPS-capable cellular phones, as its development was accelerated by the US FCC's 911 requirement to make cell phone location data available to emergency call dispatchers. Description: standalone self-ruling GPS units depend solely on radio indicators from satellites. AGPS develops that by likewise using cell tower data to enhance unwavering quality and precision when in poor satellite signal conditions. In exceptionally poor signal conditions, for example, in urban territories, satellite signs may endure multipath propagation where signals skip off structures, or are weakened by barometrical conditions, dividers, or tree spread. Some standalone GPS route gadgets, when utilized within poor conditions, will be unable to fix a position because of satellite sign fracture and must hold up for a finer satellite indicator. A GPS unit may require as long as 12.5 minutes to resolve the problem and be able to provide a correct location. An assisted GPS system can address these problems by using data available from a network. Utilizing this system can come at a cost to the user. For billing purposes, network providers often count this as a data access, which can cost money depending on the plan. To be more precise, AGPS features are mostly dependent on an internet network and/or connection to an ISP. A mobile device featured with AGPS can work only when there is an internet link connection to an ISP/CNP. It is useless in areas with no coverage of internet link to connect to those AGPS servers. On the contrary, a SGPS device feature requires no connection to internet network to obtain GPS data since it connects directly to GPS satellites swarming overhead in low Earth orbit. Assistance falls into two categories: mobile station-based, information used to acquire satellites more quickly. It can supply orbital data or almanac for the GPS satellites to the GPS receiver, enabling the GPS receiver to lock to the satellites more rapidly in some cases. The network can provide precise time. Mobile station-assisted, calculation of position by the server using information from the GPS receiver. The device captures a snapshot of the GPS signal, with approximate time, for the server to later process into a position. The assistant server has a good satellite signal, and plentiful computation power, so it can compare fragmentary signals relayed to it. Accurate, surveyed coordinates for the cell site towers allow better knowledge of local ionospheric conditions and other conditions affecting the GPS signal than the GPS receiver alone, enabling more precise calculation of position. As an additional benefit, in mobile station-assisted implementations, the amount of processing and software required for a GPS receiver can be reduced by offloading most of the work onto the assistant server. A typical AGPS-enabled receiver will use a data connection to contact the assistant server for AGPS information. If it also has functioning autonomous GPS, it may use standalone GPS, which is sometimes slower on time to first fix, but does not depend on the network, and therefore can work beyond network range, and without incurring data usage fees. Some AGPS devices do not have the option of falling back to standalone or autonomous GPS. Many mobile phones combine AGPS and other location services including Wi-Fi positioning system and cell site multilateration and sometimes a hybrid positioning system. High-sensitivity GPS is an allied technology that addresses some of these issues in a way that does not require additional infrastructure. However, unlike some forms of AGPS, high-sensitivity GPS cannot provide a fix instantaneously when the GPS receiver has been off for some time. Basic concepts: standalone GPS provides first position in approximately 30–40 seconds. A standalone GPS needs orbital information of the satellites to calculate the current position. The data rate of the satellite signal is only 50 bits, so downloading orbital information like ephemerides and the almanac directly from satellites typically takes a long time, and if the satellite signals are lost during the acquisition of this information, it is discarded and the standalone system has to start from scratch. In AGPS, the network operator deploys an AGPS server. These AGPS servers download the orbital information from the satellite and store it in the database. An AGPS-capable device can connect to these servers and download this information using mobile network radio bearers such as GSM, CDMA, WCDMA, LTE, or even using other wireless radio bearers such as Wi-Fi. Usually the data rate of these bearers is high, hence downloading orbital information takes less time. Modes of operation. AGPS has two modes of operation: mobile station assisted. In MSA mode AGPS operation, the AGPS-capable device receives acquisition assistance, reference time and other optional assistance data from a mobile service provider. The mobile service provider continuously logs GPS information from the GPS satellites using a GPS server in its system. With the help of the above data, the AGPS server calculates the position and sends it back to the AGPS device. Mobile station-based. In MSB mode AGPS operation, the AGPS device receives ephemeras, reference location, reference time and other optional assistance data from the AGPS server. With the help of the above data, the AGPS device receives signals from the visible satellites and calculates the position. Standards. AGPS protocols are part of positioning protocol defined by two different standardization bodies, 3GPP and Open Mobile Alliance. Control Plane Protocol. It is defined by 3GPP for various generations of mobile phone system. These protocols are defined for circuit-switched networks. Following positioning protocol has been defined. RRLP. A Euro 3GPP defined RRLP or Radio Resource Location Protocol to support positioning protocol on GSM networks. TIA 801. A Euro CDMA 2000 family defined this protocol for CDMA 2000 networks. RSC Position Protocol. A Euro 3GPP defined this protocol as part of the RSC standard for UMTS network. LPP. A Euro 3GPP defined LPP or LTE positioning protocol for LTE networks. User Plane Protocol. It is defined by OMA to support positioning protocols in packet-switched networks. Two generations of user plane protocol have evolved. SUPL v1.0, SUPL v2.0. See also, List of devices with assisted GPS, mobile phone tracking, references.